According to ancient mythology, Atlas supported the entire globe on his shoulders. A more appropriate modern myth has been substituted today for our era, an era of supersonic speed. It's the steel myth, this tenacious, powerful, universal metal that's been the mainspring of the unrelenting march of progress. After the Stone Age, the Bronze and Iron, came the Steel Age, steel that's transformed into bread. Steel that plows the vast open seas. Steel that spins through the blue unknown. Here are some views which show better than any other way the already traditional aspects of our epoch. Our great-grandsons will remember us looking at these emblems of our age. The men handle, work, bend the steel to their needs like the ancient artisans did with wood. They direct the finished steel on rolls towards one of its multiple purposes. With steel machines, they create other machines, other steel instruments, and even those reserved for the more domestic duties, like these contented guests in our homes. And like these who will save precious human lives. Steel on steel ships that sail across the oceans under all kinds of conditions. Perhaps these means of transport, in the silence of the hold, in the engine room, feel a fraternal link. Steel, the pivot on which the world turns. After centuries of cruel effort, Atlas takes a holiday. Steel, like bread for the human organism, is fundamentally important to life and the various needs of our society. There is an exact parallel between the values of bread and of steel. Here are some figures. The degree of civilization of a people is judged by the amount of steel consumed annually by each single individual. The world demand for steel is continually increasing. But this is only a prologue. Let's begin our story and follow this highly civilized creature from its birth. It's found in mineral form in the heart of the earth. One of its names now is magnetite. An organization like Fiat, with a vertical production structure with complete work cycles, begins with the raw material itself. The ore is mined in more or less deep pits, and once it's seen the sunlight, it's sent to the washeries where it undergoes a preliminary concentration, and then on to the iron and steel works. To make a long story short, let's give a hasty resume. There are 19 Fiat factories in Turin. And here's Turin itself, in its full role as the production and working capital of Italy, a city that mixes work with kindness and greatness. Today's monuments are visited like this, from the air. Let's fly over some of the largest industrial plants in Europe. 80,000 employees, 6,800 acres of ground. We are taking a leisurely look by helicopter of these plants, which are all grouped under one organization. The mechanical workshops that must assure the quality of the product and aim always for continuous progress are constantly being restocked by the iron and steel works, which knows hour by hour how much is expected of it. The ancients gave the names of land, water, air to the three cosmic elements. A very famous slogan changed them to land, sea, and sky. There's a fourth one, fire, and this is the principal character of our story. Here we are at the iron and steel works. Fiat, as is common knowledge, begins its manufacturing cycle with the raw material, that is to say, steel. Fiat's chief care has always been to have works and equipment capable of a high-class production of iron and steel. Fiat iron and steel manufacture is now among the very first in Europe, thanks to a complete modernization of the existing plants and the installation of new and up-to-date equipment. Fiat is in a position to cover not only its own steel requirements, but also those outside. Now the ore arrives directly at the factory, but it's no longer alone. Complementary special raw materials are added before it's sent on to the electric furnace to be transformed into pig iron. The history of the Fiat Iron and Steel Works began in 1918 with the remodeling of the two factories at Turin and Avigliana. A lot of ground has been covered since then. Among the more modern plants in the Turin factory there are an open hearth mill with 6 furnaces, an electric steel mill with 4 furnaces, a blooming mill followed by a continuous billet rolling mill, a complete installation for the production and tickling of cold rolled steel strips, a 4-cylinder reversible mill and annealing furnaces, a 24-stand continuous rolling mill for strips and bars. At Avigliana, a rod and wire drawing department, a section for cold rolling thin metal strips, a section for screws and bolts. The dazzling monstrous pig iron now empties into the ladle, where it will soon make its first trip. Still hot, the pig iron is loaded on the train, which takes this for its first breath of fresh air. The earth isn't alone in furnishing this raw material. It comes from the sea, too, from the ships after many years of plowing the seas. The acetylene torch splits effortless the sides of a ship that once resisted the furious pounding of the waves. It's there in the form of scrap, riches that many are quite unaware of. Through numberless channels, the scrap comes first to the small scrap yards. Colorful heaps of discarded metal articles are found here. Rails, steel cables, car wheels, used piping, old tools, all that wear and tear has made useless. Here we are in a huge scrap yard. The crane bucket, better known as a polyp in this kind of metal purgatory, is sending it towards a rebirth by emptying it into huge buckets. Its wide open jaws eat everything. The electromagnetic cranes don't play favorites, and everything that comes into their range are taken up and unloaded quickly. Here the scrap takes its last breath of air. It's the furnace antechamber. It seems almost to hear its furious whistle. In the furnaces, sometimes mixed with pig iron, the scrap is converted into steel. Fiat uses 2 different methods to obtain this important product: electric furnaces that produce special steels, and open hearth furnaces that give mild or ordinary steels. A gigantic ladle takes the scrap to be melted into the flames of an open hearth furnace. The temperature, which is more than 1600 degrees centigrade, melts the metal. Heat is provided by burning natural gas, which has now replaced oil as a fuel. While in the furnace, the metal is enriched with special alloys which deoxidize it and give it, besides decreasing or increasing the carbon content, certain predetermined characteristics. These electric furnaces can hold up to 60 tons of metal. The heat required for melting the metal, in this case too, over 1600 degrees centigrade, is supplied by a voltaic arc flashing between 3 enormous graphite electrodes. Each furnace is fed through transformers with a power of 18,750 kilowatt ampere and gives each day in 5 heats 300 tons of steel. 3 of the 4 furnaces in use today are among the most powerful in Europe. In a short time, all the metal in the furnace has become liquefied. All the liquefied matter has been subjected to the necessary composition corrections. The first operation is tapping, or emptying the furnace. The molten metal is run off into huge containers called ladles. The fire clay plug having been broken, the metal runs out into the ladle through a spout. When the ladle is full, the slag which floats on the molten metal overflows. And here, full of molten steel, the ladle reaches the pouring pits in which the ingot molds are laid. When solidified, the metal forms ingots. The pouring is done by alternately opening and closing a hole in the bottom of the ladle and thus filling the ingot molds. An energetic bang on the gong calls for another ladle. The electric furnace is ready now for another heat. In this furnace, the material falls from above, like into a pit. The pouring from the electric furnaces is different to that of open hearth furnaces. In the latter, a hole is made with an oxygen jet through the fire clay lining to permit the flowing out of the steel, while in the electric ones, the entire furnace is tilted until the metal flows out into the ladle, which then carries it to the ingot mold. Here the procedure is identical for both. As the steel cools, it becomes more solid and attains its first definite form, the ingot. Hurriedly leaving this dazzling spectacle, our camera takes us where the steel, hardly born, is subjected to rigorous controls which guarantee constant quality and properties. It's a kind of examination of the conscience. Chemical examinations are followed by physical and technological controls. Taken out of the ingot mold, the ingot is loaded into a so-called pit furnace, where it remains for some hours until its temperature reaches 1250 degrees. Then, from above, mighty metallic fingers seize it, lift it up delicately, and here we see that force does not necessarily need violence, and almost flying, takes it toward the hot milling machine. It's all a series of prescribed operations, all done in precise and synchronized rhythm. A short trip on the rollers, and the ingot heads towards its new goal, which we see here. The hydraulic grip sees it without pity and feeds it to the sharp teeth of the hot milling machine, where its four faces will be subjected to an energetic massage. Let's change from words to concrete facts and numbers. The Turin factory has reached an annual production of 600,000 tons of steel ingots, from which an entire range of byproducts are derived. Bars, structural shapes, hot roll strips, wire rods, sheet steel, and piping. Now let's go back to the ingot. After the hot milling machine, the blooming mill awaits it. On stage here are the gigantic pincers. Here, the rollers represent the idea of perpetual motion. A rough and energetic embrace for the young steel. Here, it's reduced to the size most suitable for further processing. This gigantic machine does work that, for centuries, man has done by his own muscular efforts or by utilizing the power of rudimental water-driven hammers. The rolls of the blooming mill, grooved in various ways, gradually reduce the cross-section of the ingot with its enormous pressure. Now it's the shearer's turn. This machine has the tranquil and sullen air of a good housewife, but it does its work with the precision of a Swiss watchmaker. Look how it cuts the bar as soon as it leaves the blooming mill, in the desired lengths. A quick slide, and away it goes to a many-stand rolling mill, which further reduces its size. When it comes out, it has changed both its appearance and name. Now it's called a billet. They take their place, one beside the other, next to those which preceded them and are now losing the heat and color of the fire. The billet is rigorously checked before passing on to successive processings, which will turn it into the finished product. Surface defects are eliminated by grinding, hand chipping, or machine chipping. Or by means of the oxyacetylene torch. Now it's time for the hammers. The hammer seems to hesitate, but it's waiting to see that everything is all right before beginning the hammering. This operation is called forging. Special steels for particular purposes requiring special characteristics are subjected to this process. The product we see here is a crankshaft. The mold surface, connected to the head of the hammer weighing 12,000 kilograms, is covered with pitch by means of a long rod. But another hammer awaits it. It's milder than the other one. It only frees it from its fin. This is the control booth at the 750 millimeter mill. Guided at a distance by the operator, the piece is subjected to this new transformation cycle. In a series of trips back and forth, the piece becomes longer, reducing its own section across a system of rollers with various groovings. It's easy to guess how much pressure has been used to make it so svelte. What a way to reduce. As soon as one piece has been sent on, another arrives for the same treatment. It never stops. Here's the 300 millimeter mill. Special steel is transformed here into round rods of smaller diameter. It's handled by hand because the bars are lighter. And now for a real act of skill. We are at the wire rod mill. The operator with lightning movement seizes the serpent-like incandescent wire and rolling it around his own body, places it into the last pair of rolls. Steel wire is made from the product of this mill. A billet comes out of a furnace. It's headed for the 24-stand continuous rolling mill for strips and rods. The worker's duty here is only to watch, simply and purely. In a few seconds, the billet is changed into a coil of incandescent wire that's wound quickly on a reel, where it is then transferred to a conveyor belt. It's necessary to cool it, but it's only a question of time. The same mill can be used for milling strips. These too are wound on huge reels for further processing. Bolts and screws, for instance, are made from rod and wire. This machine produces them at high speed. And yet again, still from wire, springs. These will definitely retain the darting aggressiveness of the fiery serpent. The finished springs are ground. And here's another use of billets, piping. From the furnace which keeps it at the required heat, the billet, cut to size, arrives at the first press which evens up the corners. Then it goes under another press which makes a hole through it, forming a semi-manufactured product known here as a glass because of its shape. The glass, mounted on a mandrel, is then pushed into a draw bench where a series of dies of decreasing diameter convert it into a pipe. Just think of it. In 20 seconds, a 12-meter pipe has been born. Welded pipes are made by another method. These begin as a steel strip which is bent and welded as it passes continuously through an electric welder. Every 8 hours sees about 20 kilometers in 8 hours emerge. And now we come to another very important product, sheet steel. Here it is, wound in bolts like cloth. The steel passes through a long sequence of vats where it takes an acid bath which purifies it and deoxidizes the surface, livening up the metal. Rewound in coils, the sheet passes through a large coal rolling mill, one of the largest now working in Europe. A pair of rollers squeeze the strip, reducing its thickness. The strip is 6 feet wide and a roll of it weighs 15 tons. Its final thickness is 1 millimeter, but it can be from a half a millimeter to 3 millimeters thick. The production speed attained is 370 meters, or 1,215 feet per minute. When unrolled, the roll is automatically cut into sheets. Here they are. They have as yet no set destination, but we only have to choose. A car body. We are now in the heavy press shop of the Fiat Steel automobile works. Sides and roof tops of the car body are removed from underneath the press. Thousands of press sheet metal parts are produced every day in this department. Like a river fed by its tributaries, the assembly line is unceasingly fed by a network of overhead conveyors which carry the parts at precisely timed speeds to the different points where they are to be used. They meet each other here on an automobile, there on a ship, or in an airplane, or on a tractor, on an infinity of steel machines and implements. Hundreds of other products are made of steel: pins and wireless aerials, hypodermic needles and pipelines, bicycles and trains, fishing hooks, bridges, jet planes, and numberless other implements. Let's enjoy for a little while some impressive scenes. From the air, one can easily enlarge his perspective. These creations will endure for dozens of years in the functions and forms assigned to them. Then they will begin again the cycle that we have followed from beginning to end. A worn-out automobile part may become shining steel in the gearing of marine engine. The steel sheet from a salvaged ship will perhaps fly through the sky at an incredible speed. They will return to the furnace, into the maelstrom of fire, and there they will tell about their adventures of yesterday, confiding their hopes for tomorrow before dying and being born again. Again, it will be steel, still more steel, new steel.